Well, in the previous slides, we talked about how shortest path bridging MAC or SPBM is simple. I just want to illustrate how simple it is by, say, comparing the past and to some extent the present, i.e. our classic three-tier hierarchy that we spoke in the previous section, and the Fabric Connect environment of the Enterprise Campus Fabric, and how simple this is. Just to illustrate, okay, what have we got here? We've got at the bottom what we call the access layer. This is where we have our users, our devices, our PCs, our laptops, anything hanging off the network at the access layer. Some of you in the audience might refer to it as an IDF, the IDF area, Independent Distribution Frame. Now, to provide connectivity, I need a protocol to support that. So let's start with the Logical Link Control Protocol, which is 802.1. Now I need 802.1. Thank you. So this symbolizes the first protocol I'm going to use to start to build this three-tier classic traditional hierarchy. So let's get some connectivity in place. And we need some redundancy also in place. And then we go from the access layer out to the MDF, otherwise known as the distribution or aggregation layer. Again, we spoke about that earlier. One of the challenges that we have around here, of course, is the very real possibility of loops. Now, we've spoken about this already. Loops, Ethernet, loops, they don't work together. So what we need to do is break those loops. And we do that with another protocol that, again, you, I, as an engineer configuring all of this, need to be skilled up in. And that protocol is the Spanning Tree Protocol. And here we go. So far, I've got 802.1. I've got the Spanning Tree Protocol. Let's just, for reference, write these out. So I've got 802.1, and then we have the Spanning Tree Protocol. Two protocols so far, but we haven't yet fully built this environment. We need to get from the access through the aggregation distribution and out to the backbone or the core. Possibly that's where our firewall's going to be, and that's certainly where the outside world is. So again, we need to build some connectivity in at this point. And we also need to build some routing logic at the aggregation layer. For the routing logic, we need routing protocols. And a good routing protocol? I don't know. Name me one. What about OSPF? Give me OSPF. Thank you. Can you see what's happening here? I've got 802.1 giving me logical link control. I've got Spanning Tree Protocol for loop avoidance. And now we've got our routing protocols, OSPF. And that's if we choose to use OSPF. You may have other routing protocols that you need to manage as well. Now notice that we also have users, and I've marked these users out in different colors. Well, two colors here, pink users and green users. And they're there to denote virtual LANs or VLANs. VLANs, yet another set of rules to define how messages are to be handled. Thank you. Goodness me, can you see that we're getting a real stack going here? I've got 802.1, I've got Spanning Tree, I've got routing, which allows us to then leverage these VLANs for things like policy control, inter-VLAN routing. Again, we spoke about this in a previous set of slides. So far, so good, but we might need policy that says those in the HR department are allowed to communicate to those in the accounts department, or those in the accounts department can't speak to those or share resources from those in, say, HR or in marketing. So we're going to leverage these VLANs, which provides us that segmentation, but we're then going to have some access control. If-then statements of condition. Does this frame come from the HR department, going to the marketing department, carrying this application or that application? Yes, it is. Permit or deny. Those policies are built into ACLs, ACL's yet another protocol, or a set of protocols that we need to be mindful of. Can you see what's happening here? We're building a stack of protocols. Each of these protocols we need to have the skills to understand, to be able to configure, to be able to manage, to be able to report on. And handling things like moves, adds, and changes can be really quite traumatic. Let's build those ACLs in there. So we have access control lists. Yeah, quite a stack growing, wouldn't you agree? And then what? Well, there's the outside world. Let's put a big fluffy cloud out there to denote the outside world. We need to get out there. How are we going to get out there? Again, more protocols that we might need to be skilled up in, to understand, to handle, certainly to accommodate those moves, adds, and changes. Protocols like, I don't know, BGP. Give me BGP, I thank you. And protocols like, well, it's all dependent on the service providers. Maybe MPLS, maybe Lisp, maybe Trill, and maybe so much more besides. I thank you. Yes, goodness me. Okay, I think we've got the point. All of these protocols I would need to be able to understand, be able to configure, to be able to even handle some of the even quite small moves, adds, and changes. That is a lot I need to be able to understand and configure. Well, what about this world over here? Again, I've got the same connectivity requirements with Fabric Connect. The whole thing's based on Ethernet at the end of the day. So let's build that connectivity in. Lovely. And to be honest, I could go connections like this, whatever's necessary, whatever I want. I'm free to choose whatever kind of topology. It's completely topology independent. Doesn't need to be 3-tier, doesn't need to be 2-tier, doesn't need to be spine leaf. Whatever topology, it's wholly topology independent. Any configuration, say, of these green VLAN users, pink VLAN users, hey, no problem. This is all standards based. It's based on standards. Ethernet based on standards like IP. The big difference, whereas over here, I have to configure all these individual protocols to accommodate any move, any add, any change. Here, if I have a move, add, or a change, I configure at the edge. I simply provision at the edge. Here, on the right, on this side, with the traditional 3-tier, I have to configure here, 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 out there, ensure my SLAs with my service providers are correctly written and that we all dovetail together. Over here, a real simple approach, Fabric Connect, shortest path bridging, MAC in MAC. Let's just spell that out, shall we? Shortest path bridging with a small m to denote MAC in MAC encapsulation. Really simple. Quick time to value. Security is part of this Fabric Connect solution, as we spoke about in the previous slide. It's actually built in rather than here, where security is often seen as very much an afterthought, which you have to accommodate with protocols like VLANs and ACLs and so much more besides. I'll tell you one big point I want to make here. How many protocols am I listing? 1, 2, 3, 4, 5, 6, 7. And that's before we get into all those WAN protocols where those bricks were thrown at me, like the Trills, like the Lisps, like the VXLANs. Over here, just one control protocol. And that protocol is, drum roll please, ISIS. Give me a bit of ISIS. I thank you. One protocol to be concerned with. One protocol that every time you provision anything, any move, any change at the edge, ISIS takes over and programs the fabric to accommodate for that change. No requirement for engineers to go out and make configuration changes on all these various boxes that make up the fabric. Compared to this. I know which one I'd prefer. Yeah? The simplicity, a single control protocol with shortest path bridging Mac-in-Mac, otherwise known as Fabric Connect, versus the traditional 2-tier, 3-tier, based on a whole series of what are effectively patches to an inherent design weakness, a weakness within Ethernet, the protocol itself. You could argue, in fact, that what we have here on this side is Ethernet fixed. In other words, Ethernet where the problems have been fixed.